This is 9.7, Polynomial and Rational Inequalities, and we are not covering the rational inequalities part. Okay, these are inequalities, so you know from the beginning you're going to be graphing and you're going to be shading. That's always true. Okay, we're going to be solving things that usually can be written like this. Okay, some sort of quadratic, and it can have any of our inequality signs. Okay, so we're looking where this whole thing is going to be less than 0, or we're looking for the whole thing is greater than something else. Okay, now this is not as simple as it is when we're dealing with a linear inequality. When we had something like this, we could just, solve this for x essentially, and we would be able to get a graph. And that's because these things are lines. And what we're often asking when we're talking about something being greater than or less than 0, if this is your x-axis, this is basically saying when is this thing above the x-axis? Or if this said less than, when is it below the x-axis? And there's always one side that's true and one side that's false. If you have a quadratic, it's not quite that simple because you have a parabola like this maybe. And here's your x-axis. Well, it's above the x-axis, it's positive in two places that are disjoint, and it's negative in one place here. And, it can be a lot more complicated than this too. So we have to use a different process. We don't have something this easy anymore. I'm going to talk you through the steps. These sound worse than they really are. It's one of those topics that's hard to explain, but relatively easy to do. Okay, so if we have some sort of quadratic or a polynomial, we're going to work one that's maybe a little bit different. Okay, but what we have here is we're going to get a 0 on one side. Because we're going to be talking about where it's above or below the x-axis, we're going to need to be able to pretend it's an equation and solve it, and we need a 0 to be able to do that. So that's what's going on. We need a 0, and then we're going to factor as much as possible. Okay? We're going to set each factor equal to 0 and solve. And this is just like as if we were given something with an equal sign and told to solve it. All of this would pretty much get us to that. Okay? And then we're going to place the answers on a number line and then extend the number line into a chart. Okay, let me just go to the next example and we'll come back to this. Okay, so our first example is we have r plus 4 times r minus 6 is less than 0. Our first steps is to get 0 on a side. We have that. Our next step is to factor as much as possible. We have that. Our next step is to set each factor equal to 0 and solve. Okay, so I take r plus 4 equal to 0, and I take r minus 6 equal to 0. Solve these, subtract 4 from both sides here, add 6 to both sides here, and we get r equals negative 4 and r equals 6. Okay, so that part's done. What's next? We're going to put them on a number line and then extend the number line into a chart. Okay, so basically I'm going to draw a number line like this. I'm going to make sure my numbers are in order. I have a negative 4 and I have a 6. Okay, now I'm going to extend these down to make a chart. That's what I mean by this. Okay, the next step, place each factor on the left side of the chart. So over here, these are my two factors. I'm going to put an r plus 4, and I'm going to put an r minus 6, and then I'm going to draw a line right there. Now I'm going to fill out this chart. Okay. Now the way I'm going to teach you is the more universal way of doing this. The book often has you plug in actual numbers, do the complete calculations, find the answers from that. But it's really not that important that you get the exact answers. What's going to be really important is that we get the correct signs. Let's look at our next step. Okay, we've done this. Choose a test number between and beyond each number on the number line. So if we think of this as a number line, I just want to find some number in this part of the number line, in this part of the number line, and this part of the number line. So right here, just some number that's on this side. Well, negative 5 is right there, right? So negative 5, I can use that for that region. Here I have a negative number, here I have a positive number. Zeros are always great to use, so use that when you can. Okay, now I just need a number larger than 6, some number in this part, and I choose 7. You want to choose something that's easy to work with, I could have chosen 1.357 if I wanted to. I could choose 1,493.9 if I wanted to. But realistically, choose something small and easy to work with. Okay, so what we've done, if we've chosen a test number between and beyond each number on the number line. That's what we've done. We've just picked a number on each little region. Now we need to decide whether the test numbers will give you a positive number or a negative number when plugged into each factor. I'm not worried about the exact values. Sometimes we are going to be forced to choose some sort of ugly fraction. And we don't need necessarily to do the entire calculation to figure out whether we get a positive answer or a negative answer. Okay, so let's imagine plugging in a -5 to right here. -5 plus 4, that's going to give me a negative answer. -5 minus 6 is going to give me a negative answer. Now do this with 0. 0 plus 4 is positive. 0 minus 6 is negative. 7 plus 4 is positive. 7 minus 6 is positive. Okay? All right, so what we've done here is we've plugged those numbers in and decided whether we get a positive or negative for each one. Now, if you look right here, these two things are being multiplied. We use our multiplication sign rules to determine whether or not the inequality is positive or negative in each region. So right here, in this little area right here, if I plug in numbers in this area of the number line, this one gives me a negative, this one gives me a negative. So right here, I would have a negative times a negative, which is positive. Okay, now right here, if I plug in a number in this region, I'll have a positive here, but I'll have a negative here. So I'll end up with a positive times a negative, which overall is negative. Okay, in this region, if I plug in a number larger than 6, I would have a positive here, and a positive times a positive is positive. Okay. Now, for the first time, we look at this sign. Everything we've done here, we would do exactly the same, whether this is negative, not negative, less than or equal to, greater than or equal to. All of this would be the same. Now, for the first time, we look at this, and we figure out whether or not our answer should be positive or negative, okay, what they're wanting us to have, and then decide whether or not you can include the endpoints in your answer. Okay. So whatever this thing is, we want it to be less than 0. So we're wanting a negative. So we want to know what values of r, if we plug them in, is going to give us a negative answer because negatives are less than 0. Okay, so we know that. Now about the endpoints. If this is just a less than, there's no endpoints. We're going to use our intervals with parentheses. If this had been a less than or equal to, then we would use brackets as appropriate. Okay, so that part is the same as it was when we first started talking about inequalities. All right, so we've got our answer, we just have to figure out where it is. We've done all the work. We're looking for a negative answer. Our answer overall is negative in this region. Okay, so follow up, that's between -4 and +6 because this is my number line, right? So my answer is from -4 to +6. I shade between them because that's where my answer is. This had less than, not an equal to on it, so both of these are parentheses. This is our answer graph, and then pull off your interval notation from this. It's going to be -4, 6. Remember in the homework, they ask you to give the interval notation and then they ask you for the graph. I suggest doing it backwards and just entering your answer in the order that they wish.